All right, I apologize ahead of time if you can hear there's a lot of background noise at my house tonight, and with the headset on, I'm hoping that you're mostly going to hear my voice, but again, I apologize if there's distractions while I'm talking. In an earlier video and situation, we drew a tree diagram for flipping a coin 3 times, and we set up a situation where we said, well, what's the probability that all 3 would be heads, or that there would be 1 head and 2 tails in whatever order that happened. And we went through and just counted the branches. We said the probability of getting 1 head and 2 tails is 1 head here, 1 head here, 1 head here. It was 3 out of 8 branches. Okay. Now, the nice thing about these 3 tree diagrams were that the branches all were equally likely. All of these probabilities of getting a head or a tail, each of those were the same. If our events don't have equally likely outcomes, and the branches are weighted differently, then I have to indicate that when I'm drawing the picture. Maybe I have a bag that has 3 red marbles and 2 blue marbles in it. And so I'm going to shake it up and I'm going to stick my hand in. I'm going to draw a marble and look at it. I'm going to put it back in. And I'm going to shake it up and I'm going to draw a second one out. Okay, when I stick my hand into the bag and draw out a marble, it's either going to be a red marble or a blue marble. But if I just look at the tree diagram like this, the reader would think, well, I have an equal shot, an equal chance, equal probability of getting a red or a blue marble, which isn't the case. Okay. We can still draw a tree diagram to help us, to help kind of condense and simplify and visualize what's going on. But if the branches are not equally likely, then we need to label them with what their probabilities are. So in that bag of marbles, we have a total of 5 marbles, and 3 of them are red and 2 of them are blue. So when I reach in and draw one out, I have a 3 out of 5 chance of getting a red one and a 2 in 5 chance of getting a blue one. Then I'm going to put the marble back in the bag, and I'm going to draw another one out. Now, because I put the marbles back in before I drew another one, okay, I still have a 3 in 5 chance of getting a red one, 2 out of 5 chance of getting a blue one. Okay. Now, what that does then is if I want to find the probability over here that I'm going to draw 2 red marbles in a row, or maybe I want to find the probability that I'm going to draw 1 red marble, and it doesn't matter if I draw it first or second, I only want one of them. Or maybe I want the probability that I'm going to draw no red marbles, which means both of them would be blue. Okay. I can't just count the branches and say, oh, well, I have a 1 in 4 chance of getting 2 red marbles, because these are now the probabilities that each of these events will happen. Okay. Because these events are independent, because I'm putting the marble back in, okay, probability of getting a red marble the first time is 3 out of 5. Then when I put it back in and shake up the bag, I still have a 3 in 5 chance of getting it the next time. So we know that probability, that compound probability, or the multiplication rule, says the probability of ending up down this branch of the tree is going to be the product of those probabilities. So I have a 9/25 chance of getting a red marble and then another red marble. Okay, the probability of me ending up here, taking a red marble and a blue marble, is 3/5 times 2/5. Whoa, which is 6/25. Okay. The probability of going blue and then red would be 2/5 times 3/5. And the probability of going blue and then blue is 2/5 and then 2/5. I cannot write neatly on this board no matter how much I practice. and it makes me crazy. Okay. So if I want to find the probability of getting 2 red marbles in a row, I have to find that path down the tree and say red marble, and then red marble, and I'm right here. And that probability is 9/25. If I want the probability of getting only 1 red marble, there's 2 ways to do that. I can either go red and then blue, or I can go blue and then red. The probability of going red and then blue is here. Blue and then red is here. And if I say, well, either this or that counts, our OR rule from the last section, that was addition. So it says I'm going to have 6/25 plus 6/25. So that'd be 12/25. Okay. The probability of not getting any red marbles, there's only one branch of that tree that takes me there, just like there was with 2. And so I say, well, that probability is 4/25. Okay. If I want to know the probability of going all the way to the end of one branch of my tree, I multiply the probabilities down those branches to get to the end. If more than one branch satisfies the condition I'm looking at, then once I multiply to get to the end, I add up those branches of my tree. Okay. All right, we're going to turn the page. We're going to put these 3 red and 2 blue marbles back in the bag. We're going to draw one out, but instead of putting it back, we're going to set it aside and then we're going to draw again. Okay, so 3 red marbles and 2 blue marbles. I'm going to draw a marble, I'm going to set it aside, and then I'm going to draw a second marble. Okay, take a minute to draw a tree. It will look similar to this in terms of shape, red, blue, red, blue, red, blue, but your probabilities as you walk along these branches is going to change a little bit. So at your desk, go ahead and pause it, see if you can get the tree diagram drawn. Once you've drawn that, make sure you can label the probabilities of the branches. And then we're going to come back and find these same 3 probabilities. Okay. So go as far as you can. I'm going to pause the video and draw, and while you guys are drawing, and then there'll be some checkpoints to make sure you're on the right path. All right, so first marble, easy peasy, just like we had on the last page. Okay, but for the second marble, if the first one that I've drawn out is red, then instead of 3 red marbles, how many are left? There's 2. Also, how many total marbles are there now in the bag? Okay, 4. So go ahead and pause again if you are needing that help. You have to talk yourself through each situation. All of these denominators will now be 4. Okay, turn it back on once you have the probabilities filled in. All right, so if we pulled a red one out first, both blue ones are left. If we pulled a blue one out first, there's only one blue one left, but all 3 red ones are there. You can go ahead and reduce these to lowest terms if you'd like. I oftentimes, in all honesty, leave them the way they are so that my denominators here are the same if I need to add the columns together. So next, go ahead and find the probability of getting to the end of each of these paths by multiplying the probabilities of the branches. When you turn it back on, the answers will be here. So pause now. We multiply 3/5 times 2/4 to get 6/20. Reduces to be 310. I reduced them because they all reduced. Okay, next thing, we want to find the probability that I'm going to get 2 red ones in a row. The probability that I'll get 1 red and 1 blue in either order, but only one of the marbles that I drew was red. And the probability that there are no reds, which means they'll be blue, both of them. Okay, so pause again, find those probabilities, turn it back on. Only the top branch gets me 2 red marbles, and so that was 3/10. There are 2 branches, the 2 middle ones, and so we add 3/10 and 3/10 to my 2 ways of getting 1 red and 1 blue, And so that's 6/10 or 3/5. And again, there's only one branch that gives me both red, or no red marbles, both blue. And so that was 1 out of 10. Okay. Next video, we'll be talking about counting rules. Practice these some more and let me know if you need help.